Good morning, all. This is Sudha Rani. Today, let us discuss about the shortest path algorithm, that is Dijkstra's algorithm. So, before going to discuss about the Dijkstra's algorithm, let us have a look on different shortest path algorithms as well as what are the graphs. So, coming to the definition of a graph is a non-linear data structure consisting of vertices and edges. So, the graph is going to have nodes as well as the vertices. If you take example, let us take one example. Let us draw a short graph. So here, this is a short graph. Okay. So see here, if we take this is as the graph, whatever the connecting points we are having, we can consider them as the nodes. So here, these all are the connecting points. We can call this as the nodes. Totally, we are having six connecting points. So these connecting points are called as the nodes. These points are called as nodes. So node 1, node 2, node 3, node 4, node 5, and node 6. So in a graph, it travels from one source to destination. We will consider what are the different possibilities we can travel through the different nodes. So among the different possibilities, among the different traversing, again we used to calculate what is the shortest path. That is, what is the minimal cost the graph is going to be given. So these are the nodes, and here the lines between the nodes, lines which are connecting from one node to another node, these lines are called as these lines are called as edges. So the vertices can be also called as vertices can also be called as nodes. And here we are having the edges. Okay. So a graph is consisting of the node or the vertices and the edges. Here, this is the complete picture of a graph where the graph is having the nodes from 1 to 6, and it is having the vertices. And again, coming to the graph is having the two types of graph. One is the directed graph and another one is the undirected graph or the planed graph. Graphs are of two types. They are the directed graphs or the undirected graphs. What are the applications? What are the real-time applications of the graph? The real-time applications of the graphs are all the social media networking, just like the LinkedIn, Facebook, etc. So how the graphs are going to be linked up with the real life means in the here every node is a structure and contains information. If you take any personal information of a person or the user of any social media account, for example, here it can take as nodes as the person ID, name, age, locality, etc. Coming to the point of Dijkstra's algorithm. So here the main point we have to remember about the Dijkstra's algorithm, which is different from remaining shortest path algorithms, is Dijkstra's algorithm is going to have non-negative edge weights. Non-negative edge weights. So again, the graphs are categorized into two types: weighted graphs and plain graphs. Weighted graphs means where every edge is assigned with some weights, or also called as the values. That kind of graph is called as the weighted graphs. And without weights, if it is a graph is plain, then it is called as the plain graph. So what is the point here means, if graph is a weighted graph, in the Dijkstra's algorithm, the graph will have only non-negative edge weights, non-negative elements, means it have with the positive values in the Dijkstra's algorithm. And this Dijkstra's algorithm is introduced by the computer scientist Dijkstra W. Dijkstras in the year 1956. So the algorithm was named by the scientist named Dijkstras. Main points to be considered in the Dijkstra's algorithm. Here we are having the few main points which we used to consider for the Dijkstra's algorithm. Is algorithm maintains a set of visited vertices as well as the set of unvisited vertices. So in the Dijkstra's algorithm, the graph, when we are traversing in the graph, it is divided the complete nodes into or vertices into visited vertices as well as the unvisited set vertices. For example, if a node is if in the graph nodes are 1 0 to 1 1 to 2, so when we are traversing from 0 to 1, so 1 is the visited vertices, and the remaining 2 3 whatever the vertices are there, they all are considered as the unvisited vertices. So for every iteration in the algorithm, every iteration it is going to be updated with whatever the vertices it is visited and whatever the vertices it is unvisited. So, and for every iteration at every node, it is to set the shortest path. This is the first point. Into the second one, in the algorithm, in the graph, the traversing is going to be starts only from the source vertex. Traversing is going to be start only with source vertex. In the graph, we can choose any one of the node as a source vertex, and from the source vertex only the traversing used to be start. And in the visiting neighbors, and it used to visit all the neighbors vertex, and every time when it is visiting the neighbor vertex, it used to update the tentative distance. Used to update, it used to calculate every path's tentative distance, and then from among the tentative distance, it is used to calculate which is the shortest path it used to found from among the traversing which is traversed. So this traversing process used to be continuous until it reaches the destination vertex, or all the reachable vertices have been visited. One condition is either destination vertex is reached, or all the vertex has to be visited. So until these two conditions, the traversing has to be continued. So what is the need for Dijkstra's algorithm? What is the need for Dijkstra's algorithm? So what is the need for Dijkstra's algorithm is, in many applications, the Dijkstra's algorithm is used in many applications where finding the shortest path between 2 points. So this is the shortest path algorithm with some different characteristics, and it is going to calculate the optimal solution, means shortest path between the source and destination as well as any given points. And take example of routing protocols for computer networking, and in the Google Map, where it is going to find out the shortest between the source and destination. So there is a question that just now I said you that the graphs are two types, directed graph and the undirected graph. Here is a question, can Dijkstra's algorithm works on both directed and undirected graph? So the answer is yes. Dijkstra's algorithm is going to be work on both directed as well as the undirected graphs. So what is a directed and what is the undirected graph? If each edge has a specific direction, indicates the direction of traveling. So take the example, see here, again I am trying to cross one graph. See here. Take the simple one. Okay. If you take these are the points, and here this is one node, here this is one node, and here this is one node. If a particular direction used to be, if a particular direction used to be specified, means the direction, take another node. Here it is another node, right? So here from this point, from this node, we are having the two possibilities. Either we can traverse from here to here or here to, if this is a 0, 1 and 2. We are having the two possibilities traverse from the source vertex. But if the direction is already defined, if the direction is already defined, means if we are having the two possibilities also, we have to traverse from 0 to 2 instead of 0 to 1, because here the direction is already specified. This kind of the graphs are called as the directed graphs, where if this direction is not specified, if we are not having any direction, then this is called as the directed graph. Means here you can traverse from any point to any point. You can traverse from upward, forward direction or the backward direction along the edges. So if you take, so here if this is the destination point, so here you can traverse from this point to this point to this, and this point to this, or you can traverse from here to here, here to here, and here to here. That is possible in the undirected graphs. Whereas in the directed graphs, you have to traverse only from the direction which is defined. You cannot go in another directions. In some shortest path algorithms, only directed graphs is defined, and in some other algorithms, we can use either the directed graphs or the undirected graphs. Here, the Dijkstras algorithm supports both the graphs, directed graphs as well as the undirected graphs. Now, okay. Now coming to the algorithm, let us take one example graph. Let us take one example graph and try to explain the Dijkstras algorithm, how it is going to be work. See here, this we are having the nodes 0 to 6, and this is, as I said, this is the graph where we are having the values, and this is not this is undirected graph. We can traverse from anywhere to anywhere, but according to the algorithm, we are choosing one vertex or one node as the source node. So here obviously I am choosing the 0 as the source node, and let us check how we are traversing from different paths to reach the destination of 6. So here first, what are the nodes we are having totally? See here, we are having the nodes 0, 1, 2, 3, 4, 5, and 6. Okay, so these are the different nodes we are having. But when we are traversing, it's starting, we used to take every value as infinity, every value as infinity. So when I am traversing from 0 to 1, at the starting stage, I used to think that the distance to travel from 0 to 1 is always infinity. Without traversing, I cannot calculate the value, and I cannot identify what is the distance between 0 to 1. So in the initial stage, I used to take every distance, every node distance as the infinity. So 1 is infinity, in the starting stage 2 is infinity, 3 is also infinity. So whatever the nodes we are having, we used to take all as the infinity, all values as the infinity at the starting stage. So see, total how many nodes we are having? We are having nodes from 0 to 6, and at the initial stage, I am thinking that I am considering that the distance between, or distance from source to all the nodes are the infinity. Clear? Now, now let's start the traversing. Right. Now take, we are traversing, we are at the starting stage. of started with the node 0. Okay, I'm starting my traversing with the source node 0. So when we are traversing at the, when we are started at the source node, here it is traversing itself. So 0 is traversing to itself. 0 is traversing to itself. And here, as it is a weighted graph, 0 doesn't have any value, any weights. 0 doesn't have any weights. It is not having any weights. It doesn't have any self loop. So I used to take 0 as, the value for 0 is what? Value for 0 is always 0. Why? Because it is not having any value, any edge value. So I'm considering 0 values as the 0 in my first iteration. So see here then. So I'm traversing at the 0 node, and the value for the 0 node is always 0. Okay. So the value for the 0 is always 0. And when I am thinking that I'm starting at the node 0, I'm starting at node 0, the value will be 0, and the remaining all the values are as usual the infinity. Why? Because in my first traversing, I visited only the 0 node, and remaining nodes are considered as well as the infinity. Why? Because I didn't visited these nodes. And as I said, when we are traversing from different nodes, at every node it used to be balanced with visited nodes and the unvisited nodes. So here with first traversing, 0 will be considered as a visited nodes, and all the remaining nodes will be considered as the unvisited nodes. So this is the first step or the first iteration. So we complete the traversing with the node 0. Right. So see here, now we completed the traversing of 0, and now we are moving to 1. So obviously we used to take in the sequence order. After 0, we are traversing to 1. So where we are going now? We are going to node 1. See, so now we are traversing from 0 to 1. So what will be the value of node 0 to 1? The value of the edge value from node 0 to 1 is 2. So now what will be the value of 1? So the value of 1 is equal to 2. Why? Because here we are having only one possibility to traverse from 0 to 1. So defaultly I am taking the value as 2. So here same. So I taken the value as 2 for the node 1. Okay. So now we traverse what? We traverse node 0 as well as 1. So we traverse node 0 to node 1. Okay. So these two nodes are now called as what? Now these two nodes are called as visited nodes. All the remaining nodes are still be unvisited nodes. So at every node level of traversing, it has to balance both the visited nodes. What are the visited nodes or what are the unvisited nodes? So here we traverse from 0 to 1. Here we traverse from 0 to 1. So this path is completed. So now these two are what? Visited nodes, and all the remaining nodes are unvisited nodes. So still it is having the distance of infinity. So now what will be the next node to traverse? What will be the next node to traverse? The next node to traverse is node 2. Next node to traverse is node 2. Now let us see. See here. Now where we are at node 2. Just check once. Okay. So node 0 to 1 is completed. Now we have to traverse from node 0 to 2. This is our traversing. Okay. So now what are the values of node 0 to 2? Now we are traversing from node 0 to 2. As this is the only one possibility to traverse from traverse from 0 to 2. So we have to take the default value as the 6. Default value as the 6. So what will be the value of 2? The value of 2 will be 6. What we take in here. The value of 2 will be 6. Okay. So now with this, how many traversing's we completed? With this, we completed the traversing of 0 to 1 as well as the 1 to 2. So what are the nodes we covered? We covered the nodes. We covered the nodes 0. We covered the node 1. We covered the node 2. We covered the, up to now, we covered the node 2. Okay. Now, to the next node. So we completed 0, 1 as well as the 2. See here. See here. Now we have to traverse where? We have to traverse to, we have to traverse to 3. We have to traverse to 3. See here. Here to traverse to 3, I am having two possibilities. That is from 0 to 1 and 1 to 3. This is path number. This is path number 1. As I am traversing 0 to 1, 1 to 3. And another possibility is there, that is 0 to 2 and 2 to 3. 0 to 2 and 2 to 3. This is the possibility of number 2. Okay. Two possibilities I am having. Let us check what are the values for two possibilities. First of all, possibilities I am having 0 to 1 as well as 1 to 3. 0 to 1, 1 to 3. Then what are the values? What are the values to traverse? To traverse from 0 to 1, we are having the value 2 plus 1 to 3, we are having the value of 5. Totally, what is the value? We are having the value as 7. This is the possibility of, this is a possibility of number 1, traversing. Take the same for the second possibility. What is the second possibility we are having? We are having the second possibility to 0 to 2 as well as 2 to 3. No. Now, what are the values? 0 to traversing, the value is 6. Plus, the traversing is the value of 8. Is the value of 8. So, what is the total? Total is 14. Total is 14. This is with the second iteration. Clear? So, 7 is always less than the number 14. Which we is to consider? We is to consider the number 7. What is the path? The path is 0 to 1, 1 to 3. This path, it is going to be 7. This path we used to be consider. So now we are considering this path 0 to 1, the path number 1. We are considering the path number 1. Okay. So now see the next. Right. So we completed. Path number 0, 1, node number 0, 1, 2, as well as the 3. So we completed all these things. So now these are considered as what I said you, that for every iteration has to be balanced with the visited nodes as well as the unvisited nodes. So now 0 to 1 are what? 0 to 1 are the visited nodes, and remaining 4, 5, 6 are the unvisited nodes. So still the value will be infinity. After the step 3, after the traversing to node 3, still we are having 3 nodes has to be traversed. Okay, now let us see the traversing 2. We completed the node 3. Now we have to traverse to node 4. Let us see what are the possibilities it is having to traverse to node 4. Right. So here is the node 4. Again, let us check. The path from where we have to traverse. So to traverse node 4, again we are having come to the path 1. What is a path 1? 0 to 1, 1 to 3, and 3 to 4. This is what? This is path 1. This is path 1 or possibility number 1. And the second path, second is what? 0 to 2, 2 to 3, and again 3 to 4. So this is what? This is the second path, second traversing. Okay. So now take the two possibilities, two values what we are getting. The first one is what? 0 to 1, 1 to 3, 3 to 4. So what are the values we are getting? 0 to 1 is 2, 1 to 3 is 5, plus 3 to 4 is. So what is the total? Total we are getting 17 with our traversing number, possibility number 1. Now let us check the second possibility. That is again 0 to 2, 2 to 3, and 3 to 4. What are the values we are getting? 0 to 2 is 6, 2 to 3 is 8, and 3 to 4 is 10. So what is the total? And the total is 24. Total is 20. So 4, 6 plus 8, 8 plus 10, 24. So always 17 is less than 24. 17 is less than 24. So what is the value we will consider for node 4? We will take the value as 4, which is the path. Path is 0 to 1, 1 to 3, and 3 to 4. That is path number. That is path number 1 we used to consider for the node 7, node 4, where the value is 17. Okay, so where the value is 17. So now we completed the traversing of node 0 to 4. Node 0 to 4 we completed the traversing. Okay, so up to step 4. So what are the nodes we covered? We covered from 0 to 4, and these are considered as the visited nodes, and remaining nodes are considered as the unvisited nodes. So again, we are having the two unvisited nodes, that is 5 and 6. Let us check what are the values we will get and what are the possibilities traversing we are having to traverse from 0 to 5. Okay. See, now we have to traverse. Now we have to traverse to node number 5. Traverse to node number 5 from the 0. Now let us check what are the possibilities we are having to traverse from 0 to 5. Okay, again take what we are having. We are having the first possibility. Again, 0 to 1, 1 to 3, and 3 to 5. This is one first possibility. And second possibility is again 0 to 2, 2 to 3, and 3 to 5. These are the possibilities we are having. Let us check what are the values we are getting. The first one is 0 to 1, 1 to 3, 3 to 5. So the values are 0 to 1 is 2, plus 1 to 3 is 5, plus 3 to 5 is number 15. That equal to, we are getting value 22 from the path number 1. Check the same with the path number 2. Is 0 to 2, 2 to 3, and 3 to 5. So what are the values we are getting? 0 to 2 is value 6, plus 2 to 3 is value 8, plus 3 to 5 is 15. Okay, so total is 29. Here we got the two values, that is 22, which is less than the value of 29. So we used to consider whatever the less value we are getting, that the less value I got here is 20. From which path we got the value 22? From 0 to 1, 1 to 3, and 3 to 5. This again path number 1. Okay, so now we completed the traversing of 0 to 5 with these values. Now let's check the remaining one. And the last node we have to traverse is that is destination node. That is a destination node we have to traverse. And if you take the same path, so here the path number 1. So here we are having 3 to 5. Next, 5 to 6. This is one possibility. And path number 2, 2 to 3, and 3 to 4, one possibility, 3 to 4, 4 to 6. Now let us check the values, what we are getting. Okay, 0 to 1, 1 to 3, 3 to 5, 5 to 6. So what are the values? 2 plus 5, 5 plus 15, 15 plus 6. Okay, so 26, 27, 28. So we got the value as 28. 2 plus 5, 5 plus 15, 15 plus 6. 28 we got. And check with another path. Path number 2, 0 to 2, 2 to 3, 3 to 4, 4 to 6. The values 6 plus 8, 8 plus 10, 10 plus 2. Okay. So the total is 26. Total is 26. So these are the general paths, whatever we traverse up to now. These are the general paths, whatever we travel up to now. But when the nodes are increasing, the possibilities of traversing is also increasing. Means this apart from these two possibilities, we are still having some more possibilities. Traverse to node 6. Let us check what are they. 0 to 1, 1 to 3. See, what are the possibilities, new possibilities we got? 0 to 1, 1 to 3, 3 to 4, 4 to 6. Okay. So what are the values we are having? 0 to 1, 2 plus 1 to 3 is 5, 3 to 4 is 10, and 4 to 6 is 2. Okay. So what is the value? 15, 15, 17, and 19. So what is the value we got? We got 19. This is one possibility. I checked. And we can also check with another value, another possibility, that is what? 0 to 2, 0 to 2, 2 to 3, 3 to 5, 5 to 6. What is that? 0 to 2, 2 to 3, 3 to 5, 5 to 6. So what is the value we got? 0 to 2 is 6. Let's see, 8. 3 to 5 is 15. Plus 5 to 6 is 6. This is getting still more value, 21, 29, 35 we got. Okay. So what are the total values we got? Total values we got 28, 26, 19, and 35. These are the total values we got traverse from 0 to 6. So which is the least one? Which is the less value? 19 is the less value. So we will consider this value to traverse from 0 to 6. So to which path we got? 19. We got 19 from path 1, it is 0 to 1, 1 to 3, 3 to 4, and 4 to 6. So this is the, like this, we have to calculate for every iteration. We have to balance the visited nodes as well as the unvisited nodes, and we have to check for the shortest path by using the Dijkstra's algorithm. People understand my small video? Thank you.